Hello, a very good morning to Doctor, and we are from Group E. Today we are going to present our EMM 3810 Mechanical Engine Lab presentation about topic hydrodynamic journal bearing. And my name is KEAN, matrix number 206019. I have two more members, which is KANG and ZIKRI bin ROSLI. So I will give an introduction of hydrodynamic journal bearing. So this journal bearing runs in the hydrodynamic lubrication regime after startup, which operates in the boundary lubrication. The rotational speed of the journal in the bearing force oil between it and the bearing force creating an oil wedge that allows sufficient pressure to be generated in the fluid, where the bearing surface is separated from the journal surface by the lubricant film generated by the general rotation, as you can see in the picture. So the yellow color is the oil wedge, and to prevent contact between the journal and the bearing. So the journal rotation is caused by the pump of the lubricant flowing around the bearing in the rotational direction. So if the journal is not supplied with any force, so its position will maintain concentric to the bearing position. However, hydrodynamic journal bearing is placed from the concentric position relying on high speed on the journal to pressurize the fluid wedge between the bearing and journal surface. So the pressure falls to the cavitation pressure in the diverging gap zone where cavitation forms. So this system is popular because of less power consumed and requires to support heavy load at high rotational speed. And since it is less power consumed, it is more efficiency and high precision.
Hi, my name is Kang and my matrix number is 20698. So for my part, I will be talking about the application. The application we choose to talk about is the high-speed circular arc gear pump journal bearing. So here we include some of the photos we get from online, since we didn't get the real object of it. So here the first picture we can see is the body of the gear pump itself, and the second picture is the internal section of the gear pump, and the third one is the schematic diagram, or the 3D diagram of a gear pump itself. So how this work, the working of hydrodynamic bearing. As how it was discussed in the previous, the hydrodynamic bearing or the journal bearing basically use oil to support the rotor. The bearing itself has a clearance on the shaft, and the oil is injected between the bearing and shaft to handle the load from the shaft cost and the radial load from the pressure. And the pressure is created in our case is the pressure from the pumping of the fluid into the pressure chamber. For your information, the radial force is generated by the effect of high pressure hydraulic oil on the surface of the gear, and the number of teeth of the high and low pressure zone must therefore to be determined. The zone of high and low pressure depends on the outlet, inlet, and the chamber. The nonlinear dynamic of this kind of bearing has been modeled using the theory of called finite impedance formulation and mathematical modeling. The circular gear pumps comprise a driving gear, driver gear, a journal bearing, pump body, front end cover, rear end cover, and an oil seal. So you can see this in the diagram provided below. Like most gear pump, they usually configured with two twins gear, which are assembled by a couple of lateral floating bushes that act as a seal for the lateral end. Gear and floating bushes are jointly packed inside a case that encloses both the component and define the isolated space that carry the fluid from the low to high pressure chamber. These lateral floating bushes act as support for the gear shaft by means of two hydrodynamic bearings, which are hydraulically balanced in order to avoid misalignment between gear shaft and the journal bearing. For more detail When the gear is rotating, the control volume's pressure increase to push the fluid to high pressure chamber. So when the gear teeth is measures in the meshing zone, fluid is squeezed out from each of the gap of the tooth by mating tooth. So when two tooth pair contact, trap volume is generated. This may cause positive pressure peak and the onset of cavitation. On the intake side, the gear teeth are coming out of the mesh. The volume of the control volume increase so that the fluid is inhaled into the tooth gap. The process repeats itself from each revolution of the pump and therefore displays fluid at a rate proportional to the pump speed.
My name is ZIKRI ROSLI and my metric number is 205977. So, based on the picture provided by KANG, we can confirm that is a double circular arc helical gear pump, which is an external gear pump. This image depicts the progression of filling, transfer, and delivery of components of the operational cycle of a gear pump. And since the gears are interlocked, fluid cannot be moved back through the center between the gears. This specific pump is often used to pump liquid such as water, light oils, chemical, additive, resins, and solvents. Also, they are also favored in applications requiring precise dosing or high pressure output.
Next, I'll give the conclusion. In conclusion, hydrodynamic journal bearing is important as they improvise the service life of the engineering system and gives an enormous impact on the rotating machineries. The application of hydrodynamic journal bearing is commonly used in the industry due to their simple design and manufacturing environment. It is cheap in price and minimum maintenance costs. The hydrodynamic journal bearing used is the high-speed circular arc gear pump, which gives a gear pump a good gear shaft support and provides high withstand load with excellent speed and precision, where normal bearing is a shorter life and give a lot of noise and vibration. So recent years, with the improvement of the technologies, rotating machinery such as electrical motor generators, pump, compressor, high-speed machine spindles, and power plant have become increasingly powerful with higher rotation speed. And you can see that hydrodynamic journal bearing has become one of an important parts for heavy machinery in present day. So that's all from us. Thank you.